Alright, we're doing section 4.3, multiplying polynomials. Now, I was going to do a contest to see who would be able to guess how long this video is, but frankly, I have no idea how long this video is going to go. I'm going to guess this one's probably going to go about 12 to 13, maybe even 14 minutes. I was going to ask you to guess, but you can just look at the clock on the YouTube video, so that seems kind of stupid. Anyways, here we go. Hopefully you have your notes. Today we're going to learn how to multiply polynomials. So we'll be using FOIL. We'll also be using a healthy dose of the distributive properties. So on some examples, you're going to have to multiply each term in the first polynomial with each term in the second polynomial, and then add like terms. We'll get to that when we get to that. So a binomial is any polynomial with two terms. It follows that a trinomial is a polynomial with three terms. I have no idea what if it's a quadnomial or quinnomial. You can look it up and let me know. Alright, when you multiply binomials, you can use the FOIL method that you probably learned in Algebra 1. FOIL stands for first, outer, inner, and last, and reminds you to multiply the first terms, outer terms, inner terms, and last terms. So, you'll be multiplying four things together whenever you use FOIL. And example 1 is a good way to demonstrate that. We have 2a minus 5 times 3a plus 4. Now you don't have to wait for me. If you know how to do this, you can just skip ahead to the next example, or you can just let it go as you work on the example yourself. So there's the yellow line, which is the first terms. 2a times 3a gives you 6a squared. The blue is the second and the outer terms. 2a times 4, that gives us a positive 8a. Next we have the inner terms, which is green. Negative 5 times 3a, which gives us negative 15a. And last but not least, the outer terms. Negative 5 times 4, which gives us negative 20. We add all those together, and we get 6a squared minus 7a minus 20. Now, some of you might be so confident in doing this that you don't actually have to FOIL everything. You can just kind of do it in your head, write it down quickly. That's fine. I understand. Whatever it takes for you to get the answer correct. But this is the FOIL method that you probably learned, and you're going to have to get used to doing this because we're going to be doing this a lot. Special products. You're going to want to memorize these, and last year in Algebra 2 Trig, I still had students that just did not remember them by the end of the year, so when they came up, they missed some easy points. They made problems that would otherwise have been simple difficult. So just remember these. They're not that hard to learn. First, we have a plus b quantity squared. This is a squared plus 2ab plus b squared. For a minus b quantity squared, that's a squared minus 2ab plus b squared. And last but not least, you'll see this called the difference of squares, because a plus b times a minus b gives us a squared minus b squared. Now, you notice that a plus b quantity squared is what it is. Do not do this. A plus b quantity squared is not the same as a squared plus b squared. If you're not sure when this is, try plugging in numbers yourself. If you make a 2 and b 1, well, 2 plus 1 is 3. 3 squared is 9. Now, if you try 2 squared plus 1 squared, you're not going to get 9. So don't make that mistake. Likewise, don't make this mistake either. A minus b quantity squared is not a squared minus b squared. It's a squared minus 2ab plus b squared. A squared minus b squared is its own special product. So, again, do not make these mistakes. If you do it, I'm going to cry because it makes me very sad. Let's go to example 2. We have 3c plus 2 quantity squared. So you're going to want to use this special product. A plus b quantity squared equals the a squared plus 2ab plus b squared. You can substitute 3c for a and 2 in place of b. So you get 3c squared plus 2 times 3c times 2 plus 2 squared. If you expand all those terms, you get 9c squared plus 12c plus 4. Now this is a shortcut to using FOIL. You're basically using FOIL but cutting out the outer and the inner parts because you're going to get the same value when you do the O and the I. So whenever you have a perfect square binomial, you can use this method by using the special product and substituting for a and b. Example 3, 4k plus 7 times 4k minus 7. If you want to try to do these on your own, again, feel free to work on it and pause the video if you want to try it yourself, and then you can resume the video when you're ready to go. So if you've noticed, this is similar to the difference of squares. A plus b times a minus b equals a squared minus b squared. In this show, the role of a is played by 4k, and the role of b is played by 7. So you write 4k plus 7 times 4k minus 7 equals 4k quantity squared minus 7 squared. You expand that, you get 16k squared minus 49. Now, I hope you remember your laws of exponents, because remember, if you are squaring something inside of parentheses, you square both terms, the coefficient 4 and the variable k. 16k squared minus 49. Alright, example 4. 4t minus 1 times 1 plus 4t. If you take a look at that very closely, you will notice that we've almost got a potential difference of squares special product. It's actually right there. What you need to do is switch the terms in the second binomial. So changing it from 1 plus 4t to 4t minus 1. You can use the commutative property of addition to switch the terms, and you get the same thing. So now we have 4t minus 1 times 4t plus 1. We use the a squared minus b squared product. We substitute in 4t for a and 1 for b, and you get 16t squared minus 1. That shouldn't be too difficult. And again, look for these patterns when you multiply these binomials. In these homework problems that you'll be doing tomorrow in class, you're going to see a lot of it. Let's go to example 5. We have 3x plus 1 times the quantity x squared plus 2x minus 6. This is going to be a little more involved. We have to use the distributive property and apply it for each term in the binomial to each term in the trinomial. What you're basically doing is a FOIL-like process without actually drawing the lines in between. Now you can do this. You can draw a line from 3x to x squared to 2x to negative 6 and do the same for 1. But what you're really doing is just using the distributive property. So what I'm going to do is take the 3x in the first binomial and multiply it by each term in the trinomial. I'm going to do the same with the plus 1. So you have 3x times the quantity x squared plus 2x minus 6 plus 1 times the quantity x squared plus 2x minus 6. At this point, all you do is distribute each term and then combine like terms and simplify. So you get 3x cubed plus 6x squared minus 18x plus x squared plus 2x minus 6. Note the like terms just like we did in section 4.1. Combine them, and you'll get 3x cubed plus 7x squared minus 16x minus 6. So whenever you get something with a binomial and a trinomial, you use the distributive property for each term in the shorter term, I guess in this case the binomial, and multiply it by each thing in the trinomial. Example 6, we have r squared times r plus 1 r minus 1. This one's pretty simple if you see what you're looking for. You're first going to take the r plus 1 and the r minus 1 and simplify it. So you get r squared times r squared minus 1. That's the difference of squares. Now it's as simple as distributing the r squared to the binomial inside. So remember, r squared times r squared, you are adding the exponents together to get r to the 4th minus r squared times 1, which is r squared. Alright, example 7. X squared minus 2xy plus y squared times the quantity x plus y. Now we can use the distributive property like we did in number 5. I'm going to take the shorter term, which is the x plus y, and distribute the x and the positive y to each term in the trinomial. So it'll look like this. And at this point, you can go ahead and solve it yourself, reduce the terms, and get an answer. So you expand it into that. These are the like terms. Rearrange it, and your answer is x cubed minus x squared y minus xy squared plus y cubed. Whenever you get, again, a situation like this, you're going to want to start with x, or whatever one of the letters, and use the highest degree term and go decreasing in degree from from left to right. So x cubed, x squared, x, and y, and no x actually. Likewise, you're going to increase the y. So y squared, y cubed. So you're going to want to get into that habit of just stylistically writing it out that way because it's easier for me and other people to read your answer. Now, this isn't the only way to do this problem. There's another way to do this. You might have noticed that x squared minus 2xy plus y squared is a special product. It is actually x minus y squared, and you are going to have to be able to identify those in both directions. Not only identifying and be able to multiply perfect square binomials, but also identifying them in problems and putting them back in perfect square form. Now you have x minus y squared times x plus y. If I split out the x minus y's, it looks like that. What I can do now is take the x minus y and x plus y, and I have a difference of squares. So that simplifies further to x minus y times x squared y squared. Now you would just use FOIL like you did back in number 1. And if you do that, you get x cubed minus x squared y minus xy squared plus y cubed. You get the same answer. So either way works well. Obviously, not every trinomial in this situation is going to be a perfect square, so you have to learn to do it the other way. But if you see this, this might be easier for some of you. All right, last but not least, we have example 8. 3x plus y plus 1 times 3x minus y minus 1. Now again, you can use the distributive property to distribute all three terms in the first trinomial to the second trinomial. But yes, this is getting a little cumbersome. So you take the 3x from the first trinomial and you multiply it by every term in the second trinomial. You do the same with y, and you do the same with the positive 1, which I didn't write here because you don't have to. Again, expand everything and then combine like terms and simplify. And I will let you do this step by step. A lot of these terms cancel out, and you're left with 9x squared minus y squared minus 2y minus 1. Now, of course, there's another way to do this. Astute observers might have noticed that this is actually a difference of squares, and this is how you see it. First of all, I put parentheses around the y plus 1 because the associative property lets me do that. And likewise, I put a minus the quantity y plus 1 over here. So you have 3x plus y plus 1 times 3x minus quantity y plus 1. And so you have a difference of squares. The 3x refers to the a term. The quantity y plus 1 refers to the b term. So you can do this. 3x squared minus the quantity y plus 1 squared. And again, you expand. 9x squared minus y squared plus 2y plus 1. Distribute the negative sign in this trinomial, and you get the same answer that you got a moment ago. So there's more than one way to do this if it's available to you. But the key to doing all these multiplication of polynomials is to be patient. Make sure you have the correct sign when you distribute, because I was looking at some of your tests and a lot of mistakes came when distributing positive and negative signs. And make sure you get the answer by simplifying and reducing it by combining like terms. Sometimes it can be cumbersome, it can be kind of long-winded, and it's really hard to check your work because you can't really plug in numbers to see. But if you take your time, be careful, you'll be fine. So that concludes 4.3. I have no idea how long this video is. I guess I'll find out when I check tomorrow. And don't forget, if you have questions, save them for class tomorrow or post them onto the class Facebook page.